So I guess we can begin. So in assignment 1, I basically gave you some problems to solve, and the question is how did you decide to design that, right? And so last time we talked about some of the issues that arose in that design, and now I want to talk about some design patterns that can be used to address some of those issues, right? And so I want to look at up to 2 patterns today. One is Iterator Pattern, and then the command pattern. And then next week we'll look at the strategy pattern and a few other related patterns. So I should say a few words about design patterns first. One is when you look at the design pattern textbook, it's really not a textbook. It's the first couple of chapters are like real chapters, and then it goes into like a catalog. So it's and the problem becomes it's sort of like reading the Sears catalog. I mean, you can do it for a little bit, but it's like plus the first couple of chapters. At one point, they start talking, well, here's a sample problem, and we're going to do this pattern, this pattern, this pattern, this pattern. And it's like, after they mention a third pattern, you go, since I don't know what any of those patterns are yet, because I'm only on the second or first chapter, it's not making a whole lot of sense, right? So you can just hold off on reading the first couple of chapters until later. Then when we know a few design patterns, they talk about the structure, then it makes, oh yeah, now that makes sense, right? And so design patterns, they came about, but it's sort of strange that the initial impetus for design patterns came from an architect. By architect, I mean an architect that designed buildings. Christopher Alexander, he's an architect professor at UC Berkeley, and he designed various projects. And his whole idea was buildings aren't isolated. People use them, right? You live in them, and you build communities around them. And so he really wanted people to help design buildings and the structures they used and lived in. But he said the problem is they don't have the vocabulary. They don't know what they're doing, right? Because you're just ordinary people. And so he wanted to create what he called design pattern language that people could read about and then use to help design buildings. And some influential people in the software world came across his work and said, yep, that's what we need, right? And so there was this big movement to find design patterns, and the goal was they really wanted to capture what people were doing in industry in such a way that they could publish it and people could read it rather than having to go find someone in the company that knew what they're doing and work under them. Like, how can we get this knowledge out so people can read it, right, and find it? And so one of the rules was they didn't want people to publish a design pattern unless they could find 3 independent uses of this idea in actual use, right? So it really was an attempt to basically encapsulate knowledge that people were using in industry. And design pattern textbook, the main one came out in 1995, which is the same time that Java was being created. And so the two are commonly tied together because design patterns were circulating while the Java team was developing Java. So they used a lot of those ideas in Java. And there's typically a structure of design patterns when you talk about them. And we'll see that as we go forward. The other thing to note is, well, a number of years ago, the design pattern book was written by 4 people. And so you should know that The common term for that book is GOF, G-O-F, standing for the Gang of Four. And that comes from actually Chinese history. At one point, when Mao was still in charge of China, there was this famous trial they put for party leaders on trial, and they were called the Gang of Four. And somehow the four for this book were labeled the Gang of Four. And at one point, there was an annual conference on object programming, and usually there's entertainment in the middle of the conference. And so one year for the entertainment, they decided to put the Gang of Four on trial. And one of the charges against them was that their book was so popular that no one realized that there were more design patterns than 23. I think I've got 10 different books on design patterns on my bookshelf, right? So the Gang of Four textbook is the most common. I don't know if Google still does this. At one point, every engineer they hired, when they walked in the door, they hand them the Gang of Four book and said, read this. So there are a lot more design patterns than the 23 in the textbook, and we'll cover a few, but we're obviously not going to cover 10 textbooks worth of design patterns in one semester. So the first one to look at, most of you should be familiar with in some way or another. It's a very common pattern used in Java. It's called the Iterator Pattern, and usually Iterator Pattern each pattern has a purpose, right? And the purpose is we want to be able to access elements of a collection in such a way that we don't have to know about the underlying structure, right? How do I go through all elements in an array? Less underlying structure is different than a binary search tree, right? And do we really want to know, how to go left, right? Most of the time, no. Just I want to go through and find the elements I want to find, right? So that's the whole point of the iterator pattern. And since it's so common, I want to first start with talking about some concrete iterators we find in different languages. And we'll start with Java, because most people in the room use Java. And there's two types of iterators, what's called external and internal. So in Java, the most common external iterator is called the iterator. When Java first came out, they started with enumeration, and they sort of realized, no, that wasn't good enough, and so they created the iterator. Enumerations are still around, but they're not used very much, so we can sort of put them aside. When you get an iterator, it has various methods that we can call, and usually the most common ones are has next to next, right? And so then what you do is, when you've got a collection like an array list or a set or a dictionary, all the collection classes have a method called iterator, which returns an iterator, and then you can, while has next, right, give me the next thing, and I do something with it, right? And there's a few other ones. And then there's a list iterator, which allows us to do a little more things, like we can add things, delete things, like it's, start going through and say, okay, right here I want to add something, or I want to delete something. And of course, those are optional, which is sort of weird, because then how do you know you can do it if they're optional? But I assume if you're a Java programmer, at one point or another, you've used an iterator to go through something in an array list or a vector or a set or a dictionary. What would the option for those three methods depend on? It depends upon the collection, and whether the collection actually, the iterator for that collection actually implements those methods. And one problem is, now in Java, we have collections which are mutable and collections which are not mutable. And clearly, if you've got an immutable collection, you're not going to be able to add or delete to it.
I mean, you could do like some sort of pseudo pattern delivery is like recreate the collection with the new addition or removal.
But that's different, right? And then there's a split iterator, and that deals with concurrent processing, so we won't worry about that. But there's also another type of external iterator, which I won't talk about here, and that is you get readers and writers. So I can have a reader or writer on like a string and then cycle through them. That's also a form of an iterator because it allows you to cycle through the elements of a collection. But this is slightly more common. And then starting in Java 8, they finally added what we call internal iterators. And it's somewhat a mystery to me why it took them over 20 years to add this. Internal iterators are very useful, and they were common before Java was created, so it's not like it's a new idea. And so here, right, here is a typical example of using a Java iterator, right? So I have a linked list, and then I add a bunch of stuff to it, and then I ask the iterator, and I get back a generic type, right? If you don't know the concrete type of it, then I can, while next, and I can then get the next element, and then I can do something with it. And again, I just do something crazy just to say we do something with it, right? And then what happens is the compiler allows us to do some funny things. So this is basically syntactic sugar. The compiler will translate that into the above code just because it's like, oh, come on, gang. I mean, why do you want to type all this, give me the thing, and while has next, do next, right? So when you look at these two pieces of code, right, for me, the big thing isn't just typing, but the big thing is that the intent of what you want to do is clear here, right? There's only basically 3 lines, and 2 of the lines are what you actually want to do. Here, it's like, oh, what I want to do is I want to go and I want to print out all the even elements, right? That's my intent. Go through this collection, give me all the even elements. Done. But here it's like, well, I needed to go 1, 2, 3, 4, 5. I got like 5 lines left, and then go through and, oh yeah, I have to get the iterator, and then I have to cycle through them all, and I have to give me next. So the intent of what my goal is a bit more obvious here than it is above, right? There's less boilerplate code in the bottom one. But so there's 2 examples of using the iterator, one explicitly and the other one implicitly. And Python does the same thing, right? You've got an iterator, but the for loop does the same thing. Behind the scenes, it calls the iterator and cycles through for you. So like I said, yeah, that's syntactic sugar for everyone understand the meaning of syntactic sugar? Is this a phrase saying that this is syntax that's translated to that, right?
It's easier to understand, right?
It's easier to understand. It's just a little bit simpler to deal with, right? So in Python, right, here's an array of things, and I can do the for statement if I want. And that for statement is actually doing what happens below, right? It actually creates the iterator, and cycles through. The one interesting thing about the Python iterator is there's basically only one method on it, which is next. And so how do you know when you're done? It throws an error, right? So it's painful to do it the bottom way because you don't know you're done until you've got the error message, and then you have to wrap everything in the error. And so what does the for statement do? It basically wraps that error to catch it, right? But there it is. There's the Python iterator. Now we need a slight diversion. Because my understanding is some students may not be totally familiar with lambdas and closures. So starting in Java 8, there's a bunch of new features that came out. And an aside is that by the end of this month, Java 11 will be out. So there's a bunch of new features that you don't care about, right? A bunch of things. But the one we care about is they finally added lambda expressions to the language. And in general, people consider lambda expressions to be sort of functional, which is sort of weird because Smalltalk is now considered to be like the first object-oriented programming language, and you cannot write a Smalltalk program without using lambdas. It's just not possible. So lambdas were an essential and critical part of Smalltalk, which is considered to be the first object-oriented programming language. So it's sort of hard to say that lambdas are really just a functional. You only list in functional languages when the first object-oriented programming language used them everywhere. And the collection streams, yeah, really important. So 2 terms you should know. Since functional programming is becoming more popular and newer languages all have lambdas and closures, and older languages like Python and Java are including them, lambdas are something you should know about and be able to use and be familiar with. So lambda is just a function without a name, right? That's it. Right. So in Java, when you declare a method, it's public and then return type and then the name of the method, right? And in Python, it's def and then the name of the method, right? And so lambdas, that name goes away. We don't give the name. Closures, a closure will capture the environment that function is defined in. And we'll see examples of these in a minute. So the Python lambdas, the syntax is the easiest to deal with. So we'll start with Python. And the way you do it in Python is the keyword lambda, and then the argument list, colon, and then lambdas in Python are restricted to one expression, which is a limitation. Why they did that, I don't know, but it is a limitation.
Can you use a tuple with it instead to get around that?
I haven't tried. I mean, it said one expression. And now I'm going to assign it to a variable. So now inc becomes a reference to my lambda, and I can treat it like a function. Right? So I can call it. And then here I print out the result, right? And here is, lambda, which has multiple arguments, a and b. I just add them together. Then I can assign it to a variable, and I can call it, right? So it's nothing mysterious, right? It's just a function. Now here's a slightly more interesting example. So I define a function called adder, and it returns a lambda, right? So, right, there's my function, it returns a lambda, and all the lambda does is the lambda has one argument, and it then adds that argument to the argument adder. So far, so good? And now, when I call adder as a function, and I pass in 5, and I assign it, and now add 5 is a reference to a function, right? And then I can call adder 9, and it returns a reference to a function. So far, so good? And then what's k, right? K is the argument to the lambda, right? So when I say adder 5, n is 5, and now when I call adder add 5, I pass in an argument, and that becomes k.
Oh, so add 5 becomes a function.
Add 5 is a function, yes.
Okay. Is this kind of like Korean?
No,
Not quite.
not quite. Now, as an aside, right, the name Lambda and Currying come from Church's work in the 1930s. So there was a lot of work on what called Lambda calculus, which then led to functional programming, and all that happened before there were computers, right? So there was actually work done in the 1930s, right? It wasn't until actually towards the end of World War II where we started trying to develop digital computers. Analog computers have been around for a long time. But that's where the word currying comes from and the word lambda comes from.
So lambdas are a concept which is it's a concept generally associated with functional programming, which is a different paradigm from object-oriented programming.
Right.
But the object-oriented languages have recently introduced these concepts into their syntax. So using these lambdas, does it make a program, does it make our design less object-oriented? Should we be using it? Should we be avoiding it? How should we incorporate these?
So there's several things, right? The common perception is that these concepts are being introduced by functional programming. As I said, Smalltalk really was the first object-oriented programming, and they use lambdas and closures everywhere. So it makes it hard for me to then say, oh, these are just functional concepts, right? Should you use them? You should use them when they make your code easier and simpler, right? And there are lots of places where that happens.
So I can imagine that maybe there's a design pattern in object-oriented programming which would be more easily, the task would be more easier accomplished using a lambda or something like that. So using that over the design pattern makes it easier for me. So is that a valid way to use that?
Yes, and we'll see in both the design patterns, both an iterator and the command pattern, we'll see alternatives which use lambdas to make it easier.
So does that like add to scalability? Like in our last assignment, when we had our priority that we were going to determine, right? Like in another sense, that could become, and say your priority was something much more complex, you could now adjust like what the priority, your calculation for that priority a lot easier by using the lambda. Or is that not necessarily the case?
Yeah, so we won't get to it this week, but next week we'll talk about the strategy pattern. And one thing happens is on your priority queue, how do you decide which has higher priority, right? So we can use a strategy pattern to do that, but it's a fairly simple thing to do. So we could give our priority queue, and we created a lambda which takes 2 arguments, which then determines how to order those things in the priority queue, right? And the standard motivation there is, if you got a collection, you want to sort it. How do you sort it? Do you always want to sort it the same way? No, I mean, you may want to sort it in order, reverse order. And maybe you have a student object, and maybe you want to sort it by ID, maybe you want to sort it by name, by zip code, right? So how to write a sort routine where I can give you a bunch of student objects, and I can sort it by name or by ID or by zip code, right? How do we do that? Well, yeah, the strategy pattern is a way of doing that, and the lambdas are a way to make that easier. So the interesting thing here is, right, when I add add 5 becomes a function, add 9 becomes a function, and when I call add 5, it adds 5 to the argument I pass in, right? When I do it with 9, it adds 9, right? And the reason that works is because lambdas in Python are also closures. They remember their environment. So when I pass back this lambda, it remembers the value of n.
So, and presumably the environments that exist between lambdas are independent of each other. So can you kind of just think about whatever assignments that you make using lambdas as being static to themselves, not to any other lambda that you have?
Yeah, each lambda has its own environment, right?
Okay.
Because you have to be careful of, right, that n goes away after adder is done, right? But the lambdas are also closures, so they remember their environment. They keep a copy of it. And they have a separate copy. Okay, so far so good? Yeah, and so this really shows that the lambdas in Python are also closures. They know their environment. They keep a copy of their environment.
So what would happen if we called add 5 again?
Let's say you called add 5 and gave it the argument of 10.
Or no, again, like another time, second time.
Yeah, call it again. Yeah, I mean,
Okay.
it's going to add whatever argument you give it to 5. Because add 5 has its own copy of n, and n is 5, right? And so if I say adder 5 parentheses 10 now, I'll get 15.
So that's what you just talked about, it has its own closure.
Right, has its own closure.
Would it add to 5 or would it add to 6?
No. It adds to n, right? And what's n? It's 5. Right.
Add 5 gets a function that adds 5 to whatever you add to it later.
Right. If you don't think about it, it all makes sense, right? Because it's n. You add k and n. What's k? K is the argument to lambda, which is, in this case, 1. This case is 1, right? But what's n? N is there, right? So if you don't think about it too much, it all makes sense. It says k plus n, so that's what you get, right? And they're different n's and different k's.
So when you define the lambda right here that you're returning, you're also defining the argument list for the variable that you assign the lambda to, right?
So lambda has an argument. It's a function, right?
Right.
So the function needs an argument list.
Right.
And that's what happens. So the argument list is what comes before the k, before the colon.
It's just interesting that you don't do it at add 5, because you define add 5 as adder 5, which returns the function it's supposed to return. But yeah, this just kind of flips it on its head a little bit because you do it somewhere else.
Yeah, it does take a while to get used to this, but you want to get used to it, and get used to using it, because lots of places where it becomes useful. Like I said in Smalltalk, You can't write a program without using Lambda. I mean, they're everywhere. And people just do it all the time. I mean, they don't even think about it. It's like, if statements are implemented using Lambdas in Smalltalk. So the motivation for Lambdas or sorting, right? I mean, how do you sort these lists? Well, the default way is just use a default comparator, right? But that's not always what you want to use. And so I get that. But what if I want to sort by length of strings, right? So what I need to do is I need to pass in something to tell the sort algorithm how to work, right? So I can pass in a lambda and tell the sort algorithm, here's how you are going to compare items. And of course, Python is sort of wacky because what you pass in is a function with one argument. It applies that function to each element and then compares the results, right? What you really want is a function of two arguments, and so how do you compare them, right? So when I call sort on it, I can call then pass in a lambda, and it has one argument, and I'm going to just compute the length of that string. And so when I do that, I get sorted that way. But the whole idea here is, right, the same thing happens in any language, right? Any language, how do you actually sort something? You want to implement the sort algorithm once, but you want to be able to sort things differently. So you pass in a lambda or something that allows that sorting algorithm to compare the elements in different ways, different types. It's how you do it in Java. It's how you do it in C#. It's how you do it in C. It's how you do it in C++, right? Every language, the sort algorithm does that, right? There's some way of either passing the lambda or a comparator, right? In Java, because they didn't have lambdas, they had to create a class. And then, of course, in Python, it's like, well, you just want a function, so you can just pass in the function directly and it'll apply it. Yeah?
So like in terms of the example for like our student class, for like that base sort of key equals lambda x, instead of like let's say we wanted to sort them based on red ID.
Yeah.
We just put the x dot red ID.
Well, how do you get the red ID out of X, out of your student? Whatever, however you get, there's nothing mysterious with lambdas, it's a function, right? And so if you want to return the red ID of a student, how do you do that? The same way you do it in lambda, the same way you do it in a function, right? It doesn't matter. Lambdas are just functions. They just don't have a name, right? You don't do def. Lambda and Swift, well, I mean, the syntax is different, and there are different ways you do it depending upon how many arguments you've got. You've got shorthand notation, etc. Here's a lambda incrementing multiple arguments. The same adder works the same way. The one thing different is that in Swift, lambdas can have more than one expression. And so then we get a more interesting example. I get rolling sum. Again, it has one argument. We have to give the return type, which is a function which returns an integer. And I can keep a sum inside. And then my lambda inside increases that sum and then returns a sum, right? And now I create my rolling sum, and it keeps track of things. When I add 5 to it, I get 5 back. But when I add 2 to it, it adds it to the sum, and now I get 7 back. Right? So we can do weird things like this. It's not very often you want to do this, but for Java, it's more complicated. So there's some documentation you can look at. There's books out that talk about lambdas, and there's a tutorial. official tutorial, and there's a zillion websites which will give you some small examples of Java lambdas, right? So we have anonymous function. So here's an expression, right? In Java, it's just parentheses, argument list, arrow, then the actual code you want to run.
How much does this Lambda concept have to do with Lambda service?
What does it have to do with Lambda service? Nothing.
So it's just a coincidence that they're both in the same thing?
Well, they use the word Lambda because in the Lambda service, you create a function which is called. Yeah, and so we get, here's your argument list. You can have multiple statements, right? With the basic syntax for Java lambdas. And there are some shorter versions, so this can be simplified to that. If you only have one argument, you can drop the parentheses. You only have one statement, you can drop the curly brackets around it. There are times when you can drop the typing. Oh, that's interesting. Why is it happening now? So the first example is, again, I'm just creating a function called length, and it's going to take one argument, and it's going to return the length of that string, right? And then it's a function. But again, I have to specify the types, argument, and then return type, and then it has to have some sort of basic type, which is in this case function. Here it's a by function. Why? Well, because it has two arguments, which means I need argument type, return type, and then I need to assign it a lambda, which has two arguments, and then returns a single int. So things become slightly more complicated in Java because now we're specifying, is it a function, a by function, and this is sort of cheating because these examples won't run. Here's a example which will run the whole thing, because I have to import that definition, otherwise the compiler will complain, say I don't know what function means, and then I have to embed it in something, right? I can't just. So in Java 9 and later, you get a REPL or a command line where you can type in Java code and see it execute. It's not full service yet because you try this example and it won't work. There's a bunch of other types of lambdas in Java. So the predicate, which basically has an argument and returns true or false. Right, so we can do is large. There's a consumer which has input but no outputs. There's a supplier which basically has no input but returns something. And so there's a bunch of other types. So lambdas are a bit more complicated if you want to define them and pass them around. Normally in Java, you just use them as arguments to a function. So you don't necessarily declare what type they are because the argument declaration does that for you. And then there are a bunch of pre-existing interfaces which can be used as Lambda types. So in one example, if you have an interface that has one method that can be used as a Lambda type, and so Runnable example, it has one method called run, and so it's sort of painful in Java because then if you want to create a Runnable, you create a class, and it implements one method, and it's like, why do I need all this typing just to have one method, right? So now you don't have to do that. So here's an example of, well, I can create something of type Runnable and assign it a Lambda. In this case, run does not have any input. There's no argument, so no arguments. And here I'm just doing the print statement just to do something. And I can now create a new thread, which requires a Runnable. I can pass in that Lambda and then call start on it. And of course, since it's a Lambda, I could have defined it inside the argument list, right, of new thread. But just to show you. Okay, when does this print out? Well, what start does on a thread is it starts a thread. So it first has to start the thread up. Once the thread is running, it will then execute that Runnable like normal. And so after start is done, doing all the getting a thread and connecting it all up, etc., then it'll print out, right? Another example, if you've done any GUI programming with Java, there are times when it gets complicated. So I got some sort of button, right? And I want something to happen when the button is pressed, right? So we want a callback. But prior to Lambdas, you couldn't pass in a function. So what you do is you create an anonymous inner class, right? It's like, it's a pain in the butt. So I'm creating a new OnClickListener, and then I do all this stuff inside the argument list. It makes the code just miserable to read. But it's better than creating a single class just to call one function for callback, right? Well, now with Lambdas, there we're done, right? You can do this. Right, so Lambdas are useful, right? Okay, now we go back to iterators. So Java has an internal iterator called forEach. So what does it mean to be internal iterator? So here is, I'm creating an array of strings. I convert that to a list, right? And then what I can do, right, is I can call forEach. What forEach does is you pass in a lambda, and it's going to apply that lambda to each element of the collection. So you don't have to do, for a in this or while has next. You just say forEach and then give it the lambda, and it applies that to everything in the element, right?
The lambda expression is inside the forEach.
It's right there, right? Yeah. Now I could have taken that lambda and assigned it to a variable, right? And then I could have passed that variable in, but I didn't because to assign it to a variable, I have to tell you the type, right? And then I say, well, what type is that? Oh, is it a function? Is it a consumer? Is it a by function? Blah blah blah. And it's like, I don't want to worry about all that stuff. I just want to tell you what I want done when on each element, right? Is everyone completely confused now? Now this should partly answer one of the questions from last time. Once I have forEach on a collection, how do I print out all the elements? It's one line of code, right? If I want to write it to a file, it's basically the same line of code, right? I just change the lambda to write to a file. Far more flexible, right? I don't have to modify the priority queue to change whether I print out, standard out, write to a file, write to a network. I can just do forEach and then plug the right lambda in to do what I want, right? Clearly a lot better, right? Far more flexible, right? Now the reason this is called an internal iterator is the actual looping through all the elements is done inside the forEach method, right? So literally, if you look at the forEach, the implementation of it inside, you're going to realize it's going to declare, right, the argument list to be a function type, right, and then you're going to do the for a in, right, this, and then you're going to apply, take that a and pass that argument to my iterator, to the lambda, right? So when to use each? Well, if you want to do something to all the elements, then just use the internal one because it's simpler, right? You know, if you're just going to find one element and stop, right? Then you know the external iterator is going to be easier. Like, okay, I found it, I'm done. All right. When you're doing really complicated things, you might want to use the external iterator. Now, I find most of the times I just use internal iterator. In Smalltalk, you rarely use, you know, this external iterator. Why? Because there's internal iterator. If you just want to find the element, there is an internal iterator that does that for you. You tell, you know, when this is true, you're done, right? Yeah. So there's now back to design patterns. The Gang4 book has these parts. So the intent, you know, what's the goal of the pattern? Some motivation example so you understand why this might be important, when it applies, the structure, how it fits together, and that talks about all the pieces that work in this pattern, how they work together, and the consequences, right? There are good consequences and there are bad consequences. Then there's a section on how to implement it, and then there's usually some sample code. And you'll see this, all the patterns, they use this structure. So here is their structure for the iterator pattern. An aggregate, what do you mean by aggregate? I mean, it's a collection of something, right? And then the client asks the aggregator, give me your iterator, right? Whether it's an internal one or an external one. And then the iterator has some methods on it, what you can do with it. And then what they also have is there is a concrete iterator. So when the way you iterate over an array list is different than the way you're going to iterate over a binary tree, right? So there'll be a concrete iterator for the array list, there'll be a concrete iterator for the linked list, there'll be a different concrete iterator for a binary tree. But you don't want to know that. So there's also a interface, right, for what an iterator is, right? So in Java, when you ask for an iterator of a collection, you just get an iterator back. There is a concrete one there, but you don't know what it is. And they don't want you to know because once you know the concrete type, you're fixed, right? You can't swap in a vector for an array list because once you know it's a vector iterator, your code is now fixed. right? So this is the structure. Now, warning, right? I want you to implement your iterator. One warning is on assignment 2, I want you to implement an iterator. You're not to use a pre-existing iterator, right? So one way to cheat in assignment 2 is take your priority queue, convert it to an array list, and then get the array list iterator, and you're done, right? No. I want you to know how to implement an iterator. These are just the roles that they play, right? So in your case, your class is not going to be called aggregate. It's going to be called priority queue, right? And in their case, it's not going to be called concrete iterator. It's going to be called priority queue iterator, right? So you have to differentiate the roles, right? Now, there are some times in some design patterns that become so common that those roles names are used, right? One example is singleton. There's people always call it instance because that's what the book called it, right? But that's not the case here. Any questions so far?
I got one for the internal iterator. You're saying like if you want to go through all the elements using forEach, but like doesn't what is it, the enhanced for loop do that? So what's the difference?
The question is, why do we need an internal iterator when we can do the forEach, right?
The forEach versus enhanced for loops, which also goes through the entire.
I'll show you an example of why we want coming up. In general, just the forEach is somewhat limited. So Python's iterators are limited in certain ways. Java's are limited in other ways. But you'll see in a minute why. So some issues when you implement an iterator. One issue is, do you want a concrete iterator versus a polymorphic iterator? What does that mean? By polymorphic mean we don't know what type it is, right? So, here I create a string reader on a string. When I do that, I can go through all the characters of that string. But I know what type it is because I say new string reader. So I know it's a string reader, right? I know the concrete type. When I create an array list and I ask give me the iterator, I don't know the concrete type, right? The function, when you look at the function definition of the iterator method on array list, it just returns an iterator, even though it returns a class that implements the iterator interface. So we don't know its type. And so I could change this from an array list to a vector, and this loop still works, right? Because I don't know the concrete type, which makes my code more flexible. Okay, any questions? Are there any C++ people in the room? Then that has meaning to you, doesn't it? Memory leak? What? For polymorphic iterators, big problem. Why? Well, because who created the object? it's created inside the array list, right? How do you deallocate things? Because the creator now lost, right, the reference to it. And as soon as the creator loses a reference to it, how do we make sure that object gets deallocated?
So you have to store it somewhere else, but that'd probably be kind of a nuisance.
Well, what happens when you pass it around and now you got two references to it?
Mostly you create the type in, say if it's a map, you would do a map of whatever elements there are and call an iterator from that type. And then you would set the beginning of your concrete created map, set it at the beginning and go to the end.
Yeah, but then how do you deallocate the iterator?
When it deallocates once it goes out of scope.
No. No, 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 no. You haven't done no C++ yet.
Yeah, you have to do it manually.
You have to do everything manually in C++. Another issue is who controls iteration. When you have an external iterator, right, the user of the iterator controls iteration, right, because you do while has next or next, and so I can call next and go off and do all kinds of stuff, and then come back later and call next again. An internal iterator, it's all done inside. You don't have any control over who defines how you traverse. You've got two possible ways of doing it. You can have a traversal structure embedded in the object. So, for example, if you've got a binary search tree, a binary tree, it's sort of nice to have the structure right there. So you could have that structure know how to traverse. The problem with that is if you want to traverse different ways, right, then you're sort of stuck. Or you can have the iterator actually do the traversal, right? How do I go from one place to the next place? If you've got a linked list or an array, it's pretty simple, right? Because you just start from here and you go that way. But once you start getting more complicated structures, how you traverse it becomes more challenging. Robustness. So what happens when you change the collection while you're still iterating? Right? What happens? For internal iterators, it's not a problem because when you call the internal iterator, it's all done at once, so you don't have time to change it, right? But when you have external iterator, like I do here, and so I create a new vector, add a bunch of stuff, I get the iterator, and now I add a new student. Now I call has next. What should happen? You get a modification exception in Java, right? And the reason is, it should work. Say I've got a list of 3 things, right? And now I have an iterator, and the iterator has a pointer to where it currently is, right? What happens now if outside my iterator I say, oh, get rid of that element? What should I point to? The previous one, the next one? Don't know, right? Or I'm pointing here, and now I add a new element. Should the iterator know about that new element or not? Right? So in Java's solution is, yeah, when you modify the collection after you get the iterator, when you use the iterator, you'll get an exception thrown. There are other languages that have a different policy.
When there's an iterator?
Right. If I modify the collection after I get the iterator, then when I use the iterator next, I get an exception.
So like it completely voids the iterator, you can't use that anymore?
It completely voids the iterator. You can't use it anymore. Why? Because there's always tricky situations where if I delete it where I'm currently at, where should I be? If I add something, should that be there or not? What happens if I add something right here? Should the iterator know about that? Should it backtrack and add it to it or not? Well, you passed it, but it's in the collection, but you iterated through and you didn't get to it. So the various questions that arise that don't have easy answers. And you have to think through all the possible scenarios to figure out how you want to handle each one if you don't want to use Java's policy of iterator is only valid as long as there's no changes to the collection. Okay, so far so good?
Could you give an example of any language or something that does not throw an error when the list is modified? What happens then?
Yeah, not off the top of my head.
The idea of an iterator is to iterate through something. You have to know what's in there. You won't want to modify it and still continue to iterate. You don't know at that point where it is.
Yeah, the question is what should the policy be? And one policy would be you make a copy of the collection and iterate through that and allow you to modify the original one. That gets complicated, but what if the collection is big, right? You want to copy the whole thing? So in Java, the solution was, well, just, I don't know what Python does. And Swift doesn't have an external iterator, right? They have only internal iterator, so that's not a problem. Okay, now for some fun stuff. This answers a question I was asked earlier. Java streams are related to iterators. And so the idea of a stream, and a stream is a sequence of values, and you can operate on those values, right? And these operations can be chained together. Here's an example. So I have a bunch of words, and I convert it to a list so I can do this on it. And I then call a stream on my word list, and then I call a filter on it. And make it, in most languages, there's an iterator that goes through and just gives you all the elements, and there's also a filter one which goes through and says, just give me the elements in this collection that satisfies condition. There's also things like reduce. Depending upon your language, there's usually map and reduce and filter. But there are a lot of other types of these things you can do to be useful. And so here I'm just saying, give me all the elements, all the words whose length is greater than 2. And then I'm going to say, okay, filter out all the elements except those where the first character is an A. And then take those results and take those strings and map them all uppercase. And now, because of the way Java implements it, we have to then do this crazy collect thing. And so what we're doing here is we're going through a list of strings, and we select only the strings which are longer than 2, and then we select strings that start with A and then I convert all those strings to uppercase, and then I ask for a collection back. This collect says, well, again, it's the crazy Java stuff, in the sense of, when I call filter, what do I get? I get a stream back.
This is reassembling the original.
It's reassembling, well, it's taking that stream and converting it to a data type I can look at. And, what's that? Oh, this is what you do in functional programming all the time, right? This is
You do operations across the entire
collection, right?
Whenever you're done doing all your modifications, you collect it all into your data type.
Right. This is really, really common. There are several reasons for it. What you're used to doing is for I equals to 0, I less than this, plus, 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 right? And then you grab the thing out and you do something with it. And the problem with that is a lot of boilerplate code. But you do the same thing over and over again. How many times have you done for I equals 0, right? You've done it thousands of times. And it's the same thing over and over again. So why are we doing it over and over again? That's one problem, right? Here, it's like all the code, all the boilerplate is taken away, right? I'm just saying, filter this, filter, select this, select that. And so the intent of what you're doing is clear here, right? I'm doing 2 filters, 1 map, and then give me the result, right?
When you say boilerplate code, you mean code that's syntax is being reused?
No, by boilerplate, I mean, in Java, you do static void main, parenthesis, string argument list, like what? And
Like 3 or 4 functions in one line.
and in Python, you just say, you just do what you want to do, right? You don't do public void static main. You're just like, oh, I want to do these 3 lines, so I just type those 3 lines, right? So that public void static main is an example of boilerplate. You do it over and over again, right? So this, it becomes clear what you're trying to achieve without doing all this for loopy stuff and all the detail, right? Another reason this is popular is if you want to start doing things on distributed computing, right? This can be parallelized easy, right? So when you go do things on Spark, this is what you do. And then what's happening behind your scene is, oh, that collection you're iterating over, well, it's not going to be 5 strings. It's going to be, 200 gigabytes of data. And so what we're going to do is we're going to split it up into pieces, send those pieces over to different machines, apply all this to the different machines, and then we're going to collect the result and apply it again to the result, right? So we can do it in parallel. You can do that with this. As soon as you do for I equals, you can't ever do that, right? People have been working on that problem for 40 years, and it's a really, really hard problem. In another 50 years, they might solve it. But it's not solved yet, because you can put anything in that for loop, right? And so you have to figure out what you're doing in that for loop and what addresses are you using. Here, since you're not addressing anything, right, we can do it for you. That's the advantage, right? So the 2 advantages are the intent of your code becomes clearer, right? Less code writing. Now I can print it out. And if you implement this right, you worry about this being a multi-pass system, but you can do it in one pass, right? You can rearrange operations to do it. all in one pass to the collection, not multiple times. Now in the past I've taught functional programming, and like the first month is just trying to get students to stop using for loops and do this, right? Because they're so used to doing the for loops, it's like, well, I'm using a language that doesn't have for loops on purpose. It's like, how can I ever solve this problem? It's like, yeah, that's what you need to learn, is how to solve the problem without doing for I equals 1. You know, so, oh, I want to find all students of 4G, right? It's just, you know, get a bunch of students, give me, a collection of students, give me the stream, then I filter, and then collect, and I'm done.
That's a Lambda function too, the filter.
Yeah, there's Lambda right there, right? What's that? Yeah, so
So the Java, because the syntax, oh wait, no, it's not.
that is Java.
Spell has the same syntax.
That is Java. That is Java, right? That's legal Java code. Well, I didn't show you how to create the students model, but this is not pseudocode. I ran this, it works. It's just I extracted pieces out to show you the important parts.
I'm just saying that the similarity between the way Scala and Java does it is very similar. Except you could probably drop the dot string in Scala, right?
Yeah, I mean, the difference is here, when you call filter, what you get back is a collection. And then you call filter on a map on a collection. When you're done, you have a collection back. Whereas in Java, what they do is you'll get a stream back. And that's why you need that last collect thing, is to convert that stream into something you can use. You have the same problem with Python. You get an iterator back, and then you have to take an iterator and convert it to a thing you can do. I mean, this is the future, right? In all languages. If you don't know how to do this, you're not comfortable doing this, you don't use it all the time, you're in trouble, right? This is the future. A bunch of stream methods do various things, right? For each, limit, map, max, min, reduce, find first, do this, etc. Right? So the Swift people, again, it's like Scala, the filter, map, return a collection. So you just call it again and again. When you're done, you get a collection, and then you go forward, right? Python is weirder because map and reduce, well, you've got map and you've got filter, and they're functions. They're not operations on. I mean, Python is schizophrenic in that way. If you want more information about this, documentation on Java, Ruby's got a bunch of these things, and Python is sort of weird because you've got this map is a function. It's not a method, it's a function. And filter is a function, right? But that's a Python. It's like they can't make up their minds. Should it be a method and a class, or it should be a standalone function? And every time I do Python, I'm like, I first go for the classes, and I'm searching for the classes. Where's this? Where is it? Where is it? It's not there. And then, okay, it must be a function. And you go over to list of functions, and you find it. Or I start looking at the functions and it turns out to be a so it's an example, right, of the iterator, external iterators in Java was very big. When you finally get internal iterators, it's like, okay, wait a minute. I mean, that's more useful, right? And this whole idea of this chaining these operations in a collection sort of overshadows the idea of an iterator. But going back to the Smalltalk example, Smalltalk came out in the 1980s, right? And that's how they did it. They had all these map and reduce, and they have a huge list of these things that you do on collections. It's very useful.
So I've not worked with Python filters and that.
Yeah.
So here, but why is it that like for when you're the second print statement, nothing's appearing?
Yes, this is fun with Python. What does filter return? It doesn't return a collection. It returns an iterator or an iterable. And so when I call list on it, what does list do? It it takes the iterator and it goes through all the elements and returns a list. But the iterator is now at the end of the list. Oh, yes. And so the reason this one prints out empty is because even is an iterator and it's already gone through the collection. I'm done.
So you have to assign.
Yes.
You have to assign it before you print it if you don't.
Yes. But again, so it's Python and Java do this similar thing, right? When you call these functions, you don't get a collection back, you get iterator back, right? Or a collect or a stream back, and then you have to convert it to what you want and go forward. Okay? That is iterators.